Here we're given a function with absolute value in it, and we're trying to figure out which of these statements are true or false. What I'm going to do first is say, hey, absolute value is piecewise defined. Here's its piecewise definition over here. So f of x over here is also going to have a piecewise definition. We're going to have two cases. If x is less than 0, then x gets replaced by negative x. So we'll have x minus 4, and what we'll just get is negative 4. If x is positive, so if x is greater than or equal to 0, x gets replaced by x. So we'll have x plus x minus 4, which is 2x minus 4. We're going to plot this on this set of axes over here to see what this looks like. Now, if x is less than 0, we're told that we get the y value of negative 4, which is down here. But up until x equals 0, or that's the truth up until x equals 0, but after x equals 0, we get the line y equals 2x minus 4, which is a line with a slope of 2 and a y-intercept of 4, so it looks like this. Okay, so now that I have my graph, my question is, do we have an absolute minimum at x equals 0? Is this a point that is as low as we'll get on the graph, and is there any other point that's lower? Yeah, there is no other lower point. This is an absolute minimum because while this point, I believe this y value, as we said before, is negative 4, there is no other point on the graph that is lower than negative 4. Sure, you might contest that and say, well, aren't there other points that have a value of negative 4? Sure. But it is the lowest y value you'll get. You can't get a y value of negative 4.1 or negative 4.5 or negative 5. There is no lower y value on this graph besides negative 4. So indeed, we do have an absolute minimum at x equals 0. Now, is it differentiable at x equals 0? This is reminiscent of one of those sharp turns we talked about a long time ago, where if your graph does like a little corner or a cusp or a little kink in the graph, then it's not differentiable. So this is false. The graph is not differentiable at x equals 0.